Now, Mercury is the planet that's usually closest to Earth. Does that surprise you? Did me. Venus certainly gets closer to us than Mercury. It can be as close as 25 million miles. After all, Venus is the second planet from the Sun, and Earth is the third. Even Mars gets closer to Earth than Mercury. The red planet can come as close to our home as 35 million miles, as it will in the year 2287. I won't be around for that. The average distance from Earth to Mercury is 48 million miles, but Mercury is still usually the closest planet to Earth. That's because Venus is usually somewhere on the other side of the Sun for 112 days, and Mars is usually far away in its highly elliptical, almost 2-year-long orbit. That leaves Mercury zipping between the Earth and the Sun every 44 days, and thus usually closer to Earth than either Venus or Mars. Hey, good trivia question to pull on your friends, isn't it? 22 spacecraft have successfully flown to Venus, and over 30 spacecraft have flown to Mars, but only 2 have ever gone to Mercury. So, what's so hard about going there? Well, it has to do with the Sun. Mercury is not only the planet that is usually closest to Earth, it is also the planet that is always closest to the Sun, 28.6 million miles close, to be precise. Being that close to the Sun creates navigational challenges, to put it mildly. Any spacecraft going to Mercury gets accelerated by the tremendous gravitational pull of the Sun. The spacecraft will be moving too fast to go into orbit around Mercury. That's why the first spacecraft that went to Mercury, the USA's Mariner 10, merely flew by Mercury 3 times, but made no attempt to achieve orbit around Mercury. The only other ship to go to Mercury, the USA's Messenger spacecraft, took 6.5 years to get there. Now that's a trip. Messenger did achieve orbit for a period of 4 years before finally running out of fuel and crashing onto the surface of Mercury on April 20, 2015. Many other spacecraft have flown to Jupiter in about the same time or less than it took Messenger to go to Mercury. The hang-up is the deceleration of the spacecraft. Quite simply, it takes too much onboard fuel supply to fire the engines in the reverse direction and brake the speed of the ship against the Sun's great gravity. Slowing down sufficiently to get into orbit around Mercury is a no-go using rocket power. Some other way had to be found to slow Messenger down, a way that didn't use much or any fuel. Messenger was a hefty 2,400 pounds or so, loaded with 9 pieces of state-of-the-art scientific equipment. Now, 55% of the total weight, or about 1,300 pounds, was fuel. But this fuel would not be used to slow the spacecraft down. The fuel would be used for 5 engine burns associated with gravity assists and also for orbital adjustments once Messenger got to Mercury. Now, gravity assists uses the gravity of a planet and the planet's orbital velocity to either speed up or slow down a spacecraft. If the ship approaches a planet at a forward-moving angle, that is, an angle in the direction the planet is revolving around the Sun, then both the planet's gravity and the orbital velocity of the planet give the spacecraft a slingshot boost, greatly increasing the speed of the craft and sending it off in a different direction. This boost in speed can be added to by the spacecraft firing its rocket engines at just the right time. Both of America's Voyager probes use Jupiter's massive gravity to slingshot them to the outer gas giant planets and eventually out of the solar system. Gravity assist can also be used to slow down a spacecraft, as in the case of Messenger. By entering a planet's orbital path ahead of the planet's gravity pulls back on the spacecraft and slows it down. An engine burn is necessary at this time to escape the orbital path of the planet. Messenger performed 1 gravity assist flyby of Earth, 2 gravity assist flybys of Venus, and 3 gravity flybys of Mercury. Only then had Messenger been slowed enough to enter into orbit around Mercury. The probe traveled an astounding 5 billion miles to get to Mercury from Earth. That's farther than Pluto is away from Earth at its most distant. The name Messenger is an acronym, almost as clever as its intricate flight path to Mercury. Because Mercury is the fastest-moving planet, The ancient Greeks appointed Mercury as the messenger of Olympus. News traveled fast even back then. MESSENGER really stands for Mercury Surface, Space Environment, Geochemistry, and Ranging. What do you think? Did they have a contest to come up with that? Now, the good news is, there's another mission to Mercury underway right now. It is a combined ESA-JAXA space mission that is bringing 2 orbiting satellites to Mercury. The mission doesn't use an acronym for its spacecraft, it has a real name, BepiColombo. No, it's not a cartoon character. Dr. Giuseppe Colombo, after whom the spacecraft is named, was an Italian mathematician and professor of applied mechanics. He worked with NASA on the Mariner 10 mission to Mercury. Bepi is Giuseppe's childhood nickname, which everyone knew and loved him by. NASA had been content with one flyby of Mercury, the first ever, but Professor Bepi calculated that with a slight adjustment of the flight path to enable a gravity assist at Venus, Mariner 10 could fly by Mercury again and again on different orbits around the Sun. Thanks to Bepi, NASA got 3 flybys of Mercury for the price of 1. BepiColombo, the spacecraft, is scheduled to perform 9 gravity assist flybys, 1 at Earth, 2 at Venus, and 6 at Mercury itself. Each planetary deceleration slows BepiColombo relative to the speed Mercury is moving around the Sun. This will allow for orbital insertion. Otherwise, BepiColombo would head off into the Sun. Now, once in orbit around Mercury, BepiColombo's Mercury Transfer Module, or MTM for short, will release 2 satellites, one European, the MPO, Mercury Planetary Orbiter, and one Japanese, the MEO, Mercury Magnetospheric Orbiter. Both are expected to orbit Mercury for 1 year. Altogether, the MCS, Mercury Composite Spacecraft, consists of the MPO, the MEO, the MTM, and MOSIF, which protects the spacecraft from the Sun and houses the electronics for MEO. This alphabet soup of mission components highlights the other reason it is difficult to get to Mercury. After 6 gravity assist slowdowns, 6 engine burns, 18 orbits around the Sun, 6.5 years of travel time, and 9 billion miles of distance, you have to bring a tailored complex of equipment. It's like that mountain picnic you'd like to go on. You can't just drive there. You have to hike a long way up a tricky mountain trail and bring along insect repellent, sunscreen, and your hat. Oh, and lunch and beverages. It's not easy. BepiColombo has packed it all, including lunch. Nah, not really. The design is incredibly complex. Nothing can face the Sun, not even the solar panels. The solar panels must be kept turned almost to a right angle to the Sun, or the heat and particle flux will corrode the solar cells, and without electricity, you have nothing. Therefore, at right angles to the Sun, the solar panels must be extra long, as if there were only a little bit of sunshine. Bepi's solar panels are 50 feet long. The sun shield must remain gyroscopically aligned towards the Sun so that all instruments are always in the shade but still have a line of sight to what each is meant to monitor. And there are a lot of instruments, 5 in the JAXA orbiter and 11 in the ESA orbiter. It's one amazing picnic. Anyway, the science objectives are meant to add to what we have learned from the previous 2 missions to Mercury. The data collected by BepiColombo will enable scientists to study the planet's interior and composition, along with Mercury's geology and surface morphology, Mercury's magnetic fields formation and evolutionary history, the planet's solar wind interactions, and overall environment. As a metal-rich planet, Mercury may hold a vast wealth of minerals that MESSENGER failed to detect. BepiColombo launched in October 2018 and still has a long way to go before it goes into orbit around Mercury. However, Bepi has already flown past Mercury and returned new photographs. The European Space Agency is excited about its first hot mission. All of the ESA's previous missions have been cold missions to objects further out into space, such as Mars, the asteroid belt, Comet Rendezvous, and elsewhere far out in the solar system. Well, all I can say is, best wishes to BepiColombo. Let's hope all goes well on its 800 degrees Fahrenheit mission to Mercury. Let's hope that Mercury's long tail of exosphere gases, sodium, magnesium, and potassium, blown off the planet's surface by the solar wind, don't fog up the lenses or coat the solar panels. Have a nice time! Ciao, baby!
This may look like a scene from a cool sci-fi movie or an astonishing painting, but it's actually real-life footage of Mars, the very planet known for its bright rust color. Layers of rock and dust cover the planet's surface. They consist of iron-rich minerals. That's why dust on Mars is mostly iron oxide. It floats in the atmosphere and creates an orange-red haze around the planet. But Mars has some even more amazing things, like these blue speckles on its surface. They look like a wind-sculpted sea of dunes around 19 miles wide. Astronauts saw these dunes at the northern polar cap of the planet. That's a region that covers an area approximately as big as Texas. The blue dunes, formed by winds, are shaped like long weaving lines. The winds on Mars are relentless and strong. They turn the barren surface of the planet into terrains of grand beauty. These winds are influenced by many different factors. For example, temperature fluctuations to the way the planet's atmosphere circulates. The atmosphere is thin on Mars. That's the reason liquid water most likely can't exist there for any long period of time. That's why, even though Mars is only half the diameter of our planet, it has the same amount of dry land as Earth. A thin atmosphere is also the reason why wind needs to be exceptionally strong and fast to move the sand and form such shapes as these dunes. Winds usually move at 10 to 20 miles per hour on Mars. Anyway, even though the image looks pretty colorful, the dunes aren't actually blue. The bluish patches represent colder parts, while the warmer regions are yellowish-orange. The images were part of a set of photos released to celebrate the 20th anniversary of Odyssey, a spacecraft orbiting Mars. Mars has numerous sand dunes in different locations all over its surface. Some of them formed 1 billion years ago, like the ones in the Valles Marineris region. They haven't changed because both the atmospheric pressure and wind patterns there have remained the same. But some things do change. For example, some dunes get covered with frost. Here, the main dune has a series of dark patterns. It may be because frost comes and goes, depending on the season. Mars has 4 seasons, just like Earth, but they're twice as long as ours. It's because Mars needs around 2 Earth years to orbit the Sun. Seasons are harsher in the south of the planet than in the north. During southern winter, the planet is farthest away from the Sun. Mars moves pretty slowly, and its orbit is elliptical, different from the orbit of Earth, which is almost circular. Spring on Mars is a season with plenty of dust storms that start in one part of the planet and, eventually, turn into huge storms. They become so large, they blanket the entire planet. Each planet of our solar system has something that makes it special. Jupiter, for example, is not only the largest planet, more than twice as big as all other planets combined, but it also has the biggest ocean in the solar system. Jupiter is made of similar elements to the Sun. They're mostly helium and hydrogen. In the deeper parts of the planet's atmosphere, temperature and pressure increase. That's why the hydrogen gas gets compressed and turns into liquid. That gives Jupiter the biggest ocean, but it's made of hydrogen, not water. There's also a theory that somewhere halfway to Jupiter's center, the pressure increases so much that electrons start getting squeezed out of hydrogen atoms. This allows the liquid to conduct electricity as effectively as most metals do. Jupiter is rotating fast, which creates electrical currents and generates a strong magnetic field. But as a gas giant, the planet doesn't have a firm surface. The planet's swirls and stripes are cold, windy clouds of water and ammonia. Jupiter also has the iconic Great Red Spot, which is an insanely large storm with crimson-colored clouds spinning counterclockwise. Winds there are way faster than any hurricane on our planet. The Great Red Spot has slightly changed throughout time and is currently bigger than our planet. It's 1.3 times as wide as Earth. Scientists have discovered that its roots extend more than 200 miles into Jupiter's atmosphere. A regular tropical cyclone we see on our planet can only extend 9 miles from the top to the bottom of the storm. These days, the red spot is becoming smaller and taller at the same time. Jupiter also has dozens of moons and a couple of rings, but unlike Saturn's rings, these are quite faint and mostly made of dust, not ice. Also, there's a salty ocean under the surface of Jupiter's biggest moon, Ganymede. It's hidden below a thick icy crust. It's likely to contain more water than all surface water reservoirs we have on Earth combined. The theory says this ocean is around 60 miles deep, 10 times greater than the deepest point of our planet's oceans. Jupiter and Saturn contain 10 million tons of precious stones. The pressure inside these planets' atmospheres can actually turn carbon into small pieces of diamonds. If you put these diamonds under extreme temperatures and pressure, they can melt. This would probably result in some sort of diamond rain. In the beginning, our solar system was just a swirling cloud of gas and dust. It eventually developed into a spinning disk with the central star in the middle. Almost all planets in our solar system move counterclockwise around the sun. Venus is the only planet that rotates in a clockwise direction, and Uranus rotates on its side. These planets are most likely different because long ago, huge asteroids collided with them and kinda knocked them off their course. There's a chance Venus could be a habitable planet. It's definitely not a place you'd want to live now, not with its sulfuric acid clouds and tremendous atmospheric pressure. It's 90 times greater than that on Earth. Add here insanely high temperatures. The conditions on Venus are very unfavorable for people. At 863 degrees Fahrenheit, Venus is hotter than Mercury, even though it's further away from the sun. This happens because there's too much carbon dioxide in Venus's atmosphere. It traps heat, which causes the temperature to rise way higher than it's supposed to. But simulations show that around 700 million years ago, Venus might have been a nice place with moderate temperatures and liquid water. Those conditions were slightly similar to those we have on Earth now. Uranus is not a gas giant. It's actually made of ice. The atmosphere contains methane, which makes the planet look blue. It has 27 moons, 2 sets of rings, and lots of ice in its atmosphere. A day on Uranus lasts just a little bit over 17 hours. That's how long it takes the planet to complete a single rotation on its axis. But its tilt is so pronounced that most of the time, either one or the other pole is pointed toward the sun. That's why the daytime length at the North Pole is almost half a year, and a year on Uranus is as long as 84 years. If you lived on Uranus closer to its North Pole, you'd be able to see the sun in the sky for 42 years. That would be the summer. After this, the sun would go down, and you'd have to live the next 42 years in the darkness. It'd be the winter on the planet. Neptune is the most distant and the smallest of the gas giants. The gravity on the planet is similar to the one we have on Earth, but you wouldn't be able to stand on Neptune's surface. It's gas, not solid land. Triton, the biggest of the planet's moons, orbits Neptune in a very unusual way. It moves backward compared to the rest of the planet's moons. Triton is also slowly spiraling inward toward Neptune. One day, billions of years from now, it's likely to get torn apart by the planet's gravitational forces and become just a ring around Neptune. This ring will continue being pulled inward until it eventually crashes into the planet. Pluto is a dwarf planet, and a year there lasts 248 Earth years. But even though it's not even a planet, Pluto still has several interesting things to offer, like floating mountains. Pluto's nitrogen glaciers carry countless isolated hills, each up to several miles across. They're likely to be fragments of water ice from the dwarf planet's surrounding uplands. Nitrogen ice is denser than water ice, so scientists think water ice hills float in a sea of frozen nitrogen, just like icebergs in the Arctic Ocean here on Earth.
You may have heard that NASA will launch a mission to Saturn's largest moon, Titan, in 2028. And, well, a lot can go wrong. The Dragonfly spacecraft will hit a thick atmosphere at insane speed, survive a fiery plunge, hop its parachutes, and then land in a spot way colder than Antarctica. And if you're picturing a giant Star Trek-style spaceship, nah. Dragonfly is basically a high-tech drone, about the size of a Mini Cooper. So, can something that small really survive all that? Well, it better survive, especially since the project is already 2 years behind and keeps getting more expensive. NASA selected the Dragonfly mission in June 2019, and the launch was scheduled for 2026. But now, it's been pushed back to 2028. That delay alone added about $1 billion to the total cost. At this point, the project costs over $3 billion. All that money is going into building a nuclear-powered car-sized craft with 8 rotors, kind of like a drone. It'll be fast, able to travel tens of miles in less than an hour, and it will take about 6 years to get to Titan. So, if the current launch date holds, it should land over there by 2034. But why Titan exactly? Well, that's because Titan is weird in the best way. It's Saturn's largest moon. It's also bigger than our own moon and the planet Mercury. Titan's atmosphere is thick. The air pressure there is about 60% higher than Earth's, which is kind of like the pressure you feel at the bottom of a deep swimming pool. But the main reason everyone's so interested in Titan is that it has all the ingredients for life. This world is packed with complex carbon-based chemicals. On Earth, carbon is at the center of all living things. It helps form our cells and body structures, and it's involved in the chemical reactions that keep life running. Without carbon, life as we know it wouldn't exist. Then there's water. Okay, Titan is just too freaking cold to have liquid water, but there's ice. It also has clouds, rain, rivers, lakes, and seas of liquid hydrocarbons like methane and ethane. On top of that, scientists think it might have a liquid water ocean hidden under its icy crust, similar to what we believe exists on Jupiter's moon Europa. In many ways, Titan may resemble what Earth was like billions of years ago before life fully developed into what we see today. By studying Titan's chemistry and environment, scientists hope to spot chemical fingerprints that could point to past or even present life. One of Dragonfly's main targets is the Selk impact crater. Scientists think something slammed into this area a few 100 million years ago, and that impact may have piled up the right ingredients for life in one spot. We're talking about a mix of carbon, plus hydrogen, oxygen, and nitrogen. Now, on paper, this mission sounds amazing. Send a flying robot to Titan to understand how life must have begun. But when you get into the details, you realize just how hard it is. Flying a drone in such a remote world is something relatively new and, honestly, a bit daunting. There's very little room for mistakes. So, over the last few years, scientists have been running all kinds of technical tests. And that's super important, because Dragonfly isn't just getting there and flying back. It's going to spend about 2.5 years operating and exploring different spots around Titan. And since the air there is much thicker than Earth's, Dragonfly's rotors won't behave the same way they do here. If you want to know whether it can lift off, stay steady, and steer properly, you can't just guess or use normal drone experience. You have to recreate Titan's air conditions here on Earth to see how the craft will fly over there. That's why they decided to test it in this huge wind tunnel at NASA's Langley Research Center located in Virginia. But they didn't just blow regular air through it. Instead, they pumped in a gas called R-134 Freon. This gas helps them to imitate the way Titan's thick atmosphere would push and swirl around the rotors. The idea is to test how Dragonfly will handle the air pressure, check its vibrations, that kind of stuff. It was only after running simulations that the problems started to show up. And it turns out Dragonfly had quite a few. From the start, engineers knew the landing on Saturn's moon would be a huge challenge. On Mars, for example, spacecraft go through a fast, intense landing that NASA often calls the 7 minutes of terror. But on Titan, Dragonfly's descent and landing is expected to take much longer, around 2 hours. The descent will be really tough. As Dragonfly drops into Titan's atmosphere, it'll be sealed inside an aeroshell. It's basically a heat shield designed to handle the intense friction and heat during entry. NASA also designed parachutes that will deploy later and slow the spacecraft down bit by bit. These parachutes have to work for a long time, up to 110 minutes. But tests show that the aeroshell could wobble a lot or even start to tumble during that long stretch. So NASA had to adjust the parachutes to help keep the spacecraft stable. After that tough descent, we can all celebrate, right? Well, not yet. Because as soon as the Dragonfly lands on the surface, it could face a different problem – overheating. And that sounds weird, considering Titan is insanely cold, with temperatures that can drop to about minus 290 degrees Fahrenheit. So, at first, scientists thought their main job would be keeping Dragonfly warm while it stays over there. That's why the original plan was to give Dragonfly a special power source called a multi-mission radioisotope thermoelectric generator. Well, that's a mouthful. It's the same kind of nuclear-powered generator used on the Curiosity and Perseverance rovers on Mars, and it provides both electricity and heat. But when researchers ran simulations, they found the design could cause the opposite problem. If there's no wind on Titan, like on a totally calm day, Dragonfly might not be able to get rid of the heat, and then the lander could overheat. In simple terms, even on a freezing world like Titan, that generator could put out enough heat to make parts of Dragonfly too warm. And then, the mission is basically over. Titan's thick atmosphere causes another tricky problem. On Earth, the atmosphere and weather can change pretty quickly because our days and seasons move along fast. But Titan runs on a much slower clock. One full day on Titan lasts about 16 Earth days, and 1 year there takes almost 30 Earth years. Since everything changes so slowly, the atmosphere doesn't shift as suddenly as it can here. And that slow pace affects temperature too. On planets like Mars, the temperature can swing a lot between day and night. Titan isn't like that. Thanks to its dense atmosphere, the temperature stays pretty steady. Now, the changes may be small, but scientists still have to take them seriously. So they put Dragonfly through a series of tests, and it passed. Thankfully, it looks like the craft's heating and cooling system can handle those subtle shifts. Now, you might be wondering, okay, but how does it actually move around? Well, because by now you know Dragonfly is like a drone. I mean, it doesn't have wheels. It has propellers and landing skids, so it can't just drive across the ground. Instead, it's meant to travel by flying. It will take off straight up, fly to a new spot, and land again, over and over. All this makes Dragonfly an amazing engineering project. But because it's so bold, there are still a lot of concerns. That's exactly why NASA is testing everything and taking every precaution to give it the best shot. And if it works, Dragonfly could help us find clues about how life on Earth first began. Maybe we'll find signs of life out there, or maybe discover something even bigger. But it's hard to know what Titan is really hiding for now, so we'll just have to wait for 2034. So, planets with two suns, like Tatooine from Star Wars, used to sound like pure fantasy. For decades, scientists believed these systems were too unstable to exist. Two stars tugging at a planet should fling it into space or drop it into one of the suns. Except, it turns out that nature didn't get the memo. Astronomers have found a planet calmly orbiting two stars like it's no big deal. This planet lives closer to its two parent stars than any other directly imaged planet in a binary star system astronomers have ever seen. Now, direct imaging means they saw the planet's light, not just its shadow. The whole system sits about 446 light-years away, so the light we see from it today left before humans ever built modern cities. This space monster is roughly 6 times the mass of Jupiter. And even more surprising, the planet is only about 13 million years old. That sounds ancient until you zoom out a little. Earth is about 4.6 billion years old, which makes this planet basically a newborn in cosmic terms. The two suns of this monster orbit each other incredibly fast and complete a full loop in just 18 Earth days. That means their gravity constantly shifts, yanking space around them like a cosmic washing machine. Even so, the planet stays locked in its path, so it takes it 300 Earth years to finish a single orbit. So nobody fully understands how this planet formed in the first place. When two stars orbit each other this closely, their gravity usually tears apart planet-forming material before anything big can take shape. Scientists have only found a few dozen planets like this so far, and that's nowhere near enough to piece together the full story. To solve the mystery, they need more data. Now, another cool find that still needs more research is a planet so stretched by gravity that it looks like a lemon, not a sphere. This planet is nothing like the calm blue and green worlds we see in space movies. It orbits a pulsar, which is basically a star's corpse. When a massive star expires, it collapses into an ultra-dense object that spins insanely fast and blasts radiation like a cosmic lighthouse. Being near one of those means game over for anything solid. And yet, this planet hangs on, barely. The gravity stretches it, pulling harder on the side facing the pulsar than the far side, like cosmic taffy. And here's where it gets extra unsettling. When scientists analyzed this planet's atmosphere, they didn't find water or oxygen. They found helium and pure carbon. No clouds, no oceans, no chance of life. According to everything we know about planet formation, this world shouldn't exist at all. So it might not be a planet in the normal sense. It could be the exposed core of a star that got shredded, leaving behind something stuck between planet and stellar corpse. That's a pretty scary trend. The line between planets and stars keeps getting blurry. And speaking of scary, meet this guy. This system lives around two red dwarf stars. These two stars orbit each other at a distance similar to how far Jupiter sits from the Sun. Scientists found two Earth-sized planets and a third possible one squeezed right up next to the stars. One planet completes a full year in just over 2 days. Another takes about 3.5 days. The candidate planet orbits even faster. To put that in perspective, these planets sit less than 2 million miles from their star. The Moon sits about 250,000 miles from Earth. So yeah, these worlds are close. When they combined data from space and ground-based telescopes, astronomers realized they were staring at something totally new – planets that transit or pass in front of both stars. Most planets in double-star systems orbit only one star, and this setup shouldn't last long according to the rules of physics. But these planets exist anyway, calmly breaking the rules. So this guy proves that planet formation works in ways we still don't fully understand, and space clearly enjoys messing with our expectations. Now, let's crank up the horror a notch. Astronomers made the first ever 3D map of a planet outside our solar system. And not just any planet. This one is so hot, it literally tears water molecules apart. As the planet moved behind its star, the James Webb watched tiny changes in the star's light at different colors, or wavelengths. Some colors get absorbed by water vapor, others don't. By stacking all that info together, scientists figured out temperatures at different heights and locations in the planet's atmosphere. And that's how they learned that parts of its atmosphere heat up to nearly 5,000 degrees Fahrenheit, hotter than molten lava. This superhot planet sits about 400 light-years away and weighs around 10 times as much as Jupiter. It races around its star in just 23 hours. 1 year there is basically a day. And because it's so close, the temperatures get so high. Winds try to move heat around, but they totally fail. WASP 18b's atmosphere barely has any water and instead overflows with carbon monoxide. Astronomers once believed water should be common in giant planet atmospheres. This world proves water is optional, not guaranteed. Now, magma worlds are another perfect proof of that. There's a huge group of planets called sub-Neptunes, planets bigger than Earth but smaller than Neptune. For a while, some scientists hoped these worlds were Haitian planets, covered in deep oceans of water or ice, wrapped in thick atmospheres. One famous example was K2-18. Its atmosphere showed methane and carbon dioxide, but almost no ammonia. But as it turned out, lava dissolves ammonia too, so the missing ammonia doesn't prove water at all. It could just mean the planet has a global ocean of magma instead. The researchers modeled how these planets heat up, cool down, and evolve over time. They asked a simple question: do these planets ever cool enough to stop being lava worlds? And the answer was almost never. When they tested thousands of known sub-Neptunes, they say almost all of them are likely lava worlds, not water worlds. In simple terms, these planets don't breathe water vapor, they breathe rock vapor. Their atmospheres come from magma boiling, not oceans evaporating. And that changes everything. Many worlds we once labeled maybe habitable turn into hellscapes the moment you run the numbers honestly. And that means space isn't hiding Earth clones, but mass-producing furnaces and other sorts of monsters. Take this bad boy, for instance. It sits only about 64 light-years away, which is uncomfortably close in cosmic terms, and it's the nearest hot Jupiter to Earth. From afar, it looks stunning, a smooth, deep blue marble floating peacefully in space. But that color hides something absolutely brutal. On this planet, it rains glass, sideways. Winds scream across the atmosphere at around 5,400 miles per hour, fast enough to shred anything instantly. The blue color comes from tiny particles of silicate, the stuff glass is made of, floating in the air. The planet's surface temperature hits about 2,400 degrees Fahrenheit, hot enough to melt rock. That heat turns those silicates into microscopic shards of glass that whip around the planet like a worldwide sandblaster. Standing there wouldn't hurt. You wouldn't exist long enough to ever feel it. And then there's the darkest planet ever found. It reflects less than 1% of the light that hits it. It's darker than coal, darker than black paint. Light just disappears into it. Not all planets even bother with stars at all. Astronomers have found rogue planets, worlds kicked out of their solar systems. These lonely planets drift through space in total darkness, frozen and untethered, with no sunrise ever again. Now, all of this shows us that our universe isn't designed for life. Life survives despite the universe, not because of it. Earth isn't typical, it's lucky. We're only at the beginning of this discovery era. Every year, new telescopes sharpen the picture, and every year, the picture gets stranger. The more clearly we see the universe, the less it resembles our imagination. And that's the most unsettling truth of all.
Mercury, about 3.8 billion years ago. A huge asteroid is about to collide with the planet. Boom! Fragments are flying in different directions, along with the blast wave. When the dust settles, we see a crater almost the size of Lake Ontario. The most interesting thing here is the shape of the crater. It looks like a spider. A round body in the center, and a bunch of legs that spread out from the crater in different directions. But the strangest thing is that the spider's legs don't quite line up with the center. Scientists can only guess how such a landscape was formed. Some think that the picture of the spider appeared there much earlier, and the meteorite falling almost into its center was just a coincidence. But we still don't have a clear explanation of how such scars could have appeared on the surface of Mercury. Another mystery about Mercury is how it was born. One theory claims that the planet used to be Venus's moon, but over time, it succumbed to the sun's gravity. The star literally ripped Mercury away, and the little planet began orbiting it. What might prove this theory is the rotation periods of Mercury and Venus. Mercury is gradually losing its rotational speed. One day on this planet now equals 58 Earth days and continues to increase. At the same time, after losing its heavy load, Venus has started rotating a little faster. Another theory says that Mercury collided with Venus shortly after the appearance of the solar system. At that time, Proto-Mercury was slightly larger than the planet we're familiar with these days. But then, Mercury lost part of its crust after colliding with Venus. And a little later, Venus collected this debris. But scientists still can't come up with a definitive answer as to how Mercury was formed. Uranus, a gas giant, 18 Earth-Sun distances from our home. This planet seems calm compared to other giants, like Jupiter with its Earth-sized storms. And still, Uranus has something unusual to boast about. This dark spot, for example, was detected by the Hubble telescope in 2006. At that time, it was almost twice the size of Alaska. A few years later, bright spots appeared there. It turned out that they were methane clouds that moved across the surface of the planet at a speed of 300 miles per hour. But we don't know what exactly causes such storms on Uranus. Maybe we can solve this secret by looking at another mystery of Uranus. This planet rotates while lying on its side. If you look at the axis of our planet, you'll see that it's vertical and only slightly tilted. It's the same for most of the planets in our solar system. But not Uranus. Its axis is almost horizontal and pointed toward the sun. One of the poles of Uranus is fully illuminated at almost all times. The polar day on the planet lasts for 42 Earth years. When the tilt of Uranus's axis changes, the polar day starts on the other side of the planet. The other pole plunges into darkness for 42 years. This change of seasons can cause severe storms on the planet's surface. But why exactly Uranus lies on its side is unknown. Perhaps billions of years ago, the gas giant collided with several asteroids that were about to become a young planet. Such a protoplanet, similar in size and weight to Earth, could have tilted Uranus after crashing into it, but it's still just a hypothesis. Now let's go to Jupiter's moon, Europa. The big mystery here is whether there is life on this moon. Scientists don't deny such a possibility. All you see on the moon's surface is ice. The stripes you may spot are actually long, wide cracks. For a long time, scientists thought this moon was nothing more than a block of ice. But now, they think there might be liquid water inside. The core of Europa is heated by the tidal forces of Jupiter. This warm core melts the ice around it, so there really could be a huge ocean under the ice crust. Since water is the basis of life, different microorganisms could exist there. But we would only find out if we sent a probe there. We would have to drill through 24 miles of solid ice and start searching in an ocean twice the size of all water reservoirs on Earth. Look at Saturn's moon Titan. It's the second largest moon in the solar system. It's 50% bigger than Earth's natural satellite. It's the only place in our solar system, other than Earth, where liquid water has been proven to exist. But the most interesting thing about Titan is its atmosphere. It's 250 miles thick. This distance is almost 40 times greater than the average cruising altitude of commercial planes on Earth. And it's 95% nitrogen. For comparison, Earth's atmosphere is 79% nitrogen, which means they're quite similar. The mystery is that no one knows how this atmosphere appeared there. One theory suggests that many years ago, meteorites hit Titan's surface almost non-stop. Massive rocks collided with the crust, raising the pressure and temperatures on the moon. Under such conditions, the ammonia in the air decomposed into nitrogen and hydrogen. The heavy nitrogen fell on Titan's surface, while the light hydrogen rose and flowed out into space. But some scientists dispute this theory. Another mystery of the solar system is the hypothetical star Nemesis, and whether it really exists. If you look at all the stars of our galaxy, most of them are paired, which means that two stars orbit around each other. Statistically, the Sun must also have a companion. So, some scientists have made an assumption that the largest mass extinctions on Earth were related to some mysterious object in space. They hypothesized that there was a red dwarf somewhere within 1.5 light-years away from the center of the solar system, and every approach of this dwarf star to the asteroid cloud disturbed these space travelers. Every time it happened, several asteroids began their journey toward Earth and caused a mass extinction. But this star hasn't yet been discovered, and many scientists question this hypothesis. Now let's look at the very edge of the solar system. A photon of light has to travel 1 year to get here. Scientists believe the Oort cloud exists in that area. It's a hypothetical region where tons of asteroids and blocks of ice gather into clouds. It's the furthest place where the sun's gravity still works. Presumably, this spherical cloud wraps around the solar system. This is the region where long-period comets are thought to originate. They fly all the way through the solar system and then return to the Oort cloud. This journey can take thousands of years. Even more exciting, there could be a gas giant called Tyche in that region. Some scientists say it might be 4 times the size of Jupiter. So far, no research has confirmed its existence. Although the Oort cloud is still considered hypothetical, some scientists believe that comets from that area are responsible for the major mass extinctions on Earth. Now let's go beyond the borders of the solar system. There, 1,500 light-years away from Earth, there's the closest to our home planet black hole. Black holes are the most mysterious objects in the universe. They're so heavy that they attract not only matter, but also light. Even more, they slow down time. Once something gets trapped in a black hole's gravity, it never escapes. Light and matter gradually settle near the event horizon and soon disappear into infinite darkness. Time flows differently here. 1 minute near a black hole can be equal to weeks on Earth. The biggest mystery is what exactly is inside a black hole. Some speculate that there's nothing but crushing pressure that destroys anything that gets there. Others say it might be a portal to another dimension or a wormhole to another place in the universe. If it was true, white holes would exist as well, as exits from black hole portals and wormholes. But no white hole has been found so far. Now, how about going to the hypothetical border of the entire universe? It's called the Eridanus supervoid. If you look at the map of the universe, you'll see an empty cold spot about 1 billion light-years wide. The entire Milky Way galaxy is only 100,000 light-years across. The main mystery is how the spot appeared. One theory says this void is the scar left by the collision of two parallel universes. Imagine that universes are giant bubbles, and one day, two of these bubbles collided. That's when the parallel universe ripped several galaxies out of our bubble. So far, this is the only explanation for how such a huge cold void could appear in our universe.
Hey, ready to test your knowledge? Of course you are. You'll get 1 point for each correct answer. So, without further ado, the sun is yellow. Do you think this is a myth? Ask someone to draw a picture of the sun, and chances are you'll get a yellow or orange circle in the sky. Surprise! The sun is not really yellow. If you see it somewhere outside the Earth's atmosphere, it'll look white. How come? According to NASA, the sun's temperature is the reason why it's white. The sun consists of all colors mixed together, so it appears to our eyes as white. Then why do you think we see it as yellow or orange from Earth? Colored wavelengths, which are yellow and orange, are longer, and they are the only ones that make it to our eyes. The other short wavelength colors sprawl in the atmosphere, and the sky looks blue to us during the day for the same reason. Meteorites are hot as fire when they land on Earth. What do you think, myth or fact? When people see a fireball around a meteorite, they think it's super hot. Well, this is a myth. Meteorites don't immediately land on Earth. Most of them have been in space for billions of years. Space has a cold environment, just a few degrees above absolute zero cold, you know. But don't meteorites fall into the Earth in flames? How come? The fireball is actually the air in front of the meteorite. It is compressed by the super high speed of the meteorite. The outside catches fire, but that layer is burned off on impact as a result of landing on Earth. As you would probably guess, when they land, the meteorites are lukewarm at most, but not as hot as lava. One side of the moon is permanently in the dark. Do you think this is a myth or a fact? This is a myth. Oh, come on. First the sun and now the moon. Am I living a lie? So, people look at the sky and see only the bright side of the moon. The reality is the Earth shines equally on all sides of the moon as it rotates and orbits the Earth. Half of the moon is in shadow, and half gets sunshine similar to Earth. That's not true. Similar to Earth, it doesn't have a permanent dark side. The logic is simple. The moon orbits Earth, but it also rotates on its own axis. When you think about it, we're always looking at the same side of the moon. Black holes take in everything that comes their way. What is it, myth or fact? Black holes don't have infinite mass and gravitational force, but still, no one really knows for sure what happens to the things pulled into them. Experts do know black holes do not have supergravity, though. Let's imagine this. If there was a black hole as big as the sun, it wouldn't immediately eat the whole planet. Imagine black holes as vacuum cleaners. It does draw in a cloud of dust near its range, but other specks of dust remain where they are. So even if there was a black hole replacing the sun, all the planets would continue to orbit similarly. They wouldn't go into the black hole. If a star or something else got into the range of the black hole, only then would its gravity affect the star. When you call someone, the signal bounces off a satellite. Is this a myth or a fact? It's a myth, or rather an urban legend or misconception, you name it. I mean, there are some satellite phones, but we, regular people, don't use those every day. Although your mobile phone works in a much different way. When you call someone, the nearest tower connects you to the other person online. This is why there are tower connections, huge networks of tower-to-tower connections, and hidden cables. The moon has no gravity. Any guesses? Myth or fact? This is an urban legend. Ask any astronaut you know. If you don't know any, just trust me. There is footage proving that the moon has gravity. When I say the moon has gravity, don't think it's similar to the gravity on Earth that makes the apple fall. The moon's gravity is only about 1/6 of Earth's. How does it feel to walk on the surface of the moon? The second man on the moon, Buzz Aldrin, mentioned it's like moving in slow motion and, quote, perhaps not too far from a trampoline, but without the springiness and instability, end quote. The sunset on Mars appears blue. Do you think this is a myth or a fact? This is a fact. Magnificent sunsets. The sky is filled with different shades of yellow. Now imagine this in blue. According to NASA, sunsets on Mars would look bluish, watching them with bare eyes. It's because of dust. Dust particles closer to the sun appear in blue tones. There is something called moonquakes. Does it sound like a myth or a fact? It's a fact. Quakes happen on the moon too, and they're called moonquakes. They have different features, not really similar to the quakes on Earth though. A planet can be hot enough to vaporize rocks. Any guesses? Is this a myth or a fact? This is a fact. The temperature in this universe is indeed very high. There's a planet, the temperature of which is enough to melt and even vaporize rocks. It's 2 times bigger than the Earth. This super-Earth is similar to our planet, but it is way too hot. Experts believe that it possibly has oceans of lava and clouds that rain molten rock. 1 million Earths can fit inside the sun. Do you think this is a myth or a fact? This is a fact. Although the sun is one of more than 100 billion stars in the Milky Way, which is at the heart of our solar system, it can fit 1 million Earths. Yeah, it looks small when we see it from here, but it's only because it's so far away from Earth. All comets have tails. Myth or fact? It's true. Some comets simply don't show their tails. They look like someone threw a snowball into space. Space is completely silent. What do you say? Shh, I knew it was too easy. This is a fact. Space doesn't have an atmosphere, so there's no way to hear any sound there. Mercury is the hottest planet. Myth or fact? Mercury is the closest planet to the Sun, so this should be a fact, huh? No, not really. Venus is the hottest planet in our solar system and the second planet from the Sun. But the distance from the Sun isn't what defines the temperature. The heat depends on the atmosphere. So Venus's atmosphere consists mostly of carbon dioxide and some nitrogen. This combination makes the atmosphere very thick. When I say thick, I mean it. Throughout the year, the surface of Venus maintains a temperature of around 860 degrees Fahrenheit. Mercury's surface resembles the temperature of a desert, but is much higher in terms of temperature variations. Venus spins clockwise. What do you say? This is a fact. Venus spins in the opposite direction compared to many other planets. The Sun rises in the west, and its rotation is very slow. Venus needs 225 Earth days to complete its spinning around the Sun. The planet's distance from the Sun affects the duration of one rotation. It's too close to the Sun, and the Sun has a strong, noticeable pull on the planets. Footprints on the Moon can stay there for millions of years. Do you think this is a fact or a myth? Fact checked. The Moon has no atmosphere, so there's no wind blowing, and without the wind, there's no way to erase the footprints without any intervention. So, how many points did you get? Let me know in the comments. Well, NASA has just dropped the craziest news ever. They've found the clearest evidence yet that life might have once existed on Mars. So, is that what you'd see if you travel there? Well, let's imagine, shall we? The world around you is red, darker than Earth. There's a dust storm on the horizon. Suddenly, you spot a bizarre creature that makes your blood run cold. It's way taller than you, with long, creepy-looking arms and legs. Its skin is orange, and its eyes are huge. They look like some kind of shiny lenses. Come to think of it, it all makes sense. Gravity on Mars is 38% weaker than on our planet. That's why this creature has grown to be so tall. You know, when astronauts go to space, they tend to grow up to 2 inches, all because the reduced gravity makes the fluid between their vertebrae expand. As for the creature's unusually colored skin, this is protection against solar radiation. Mars doesn't have a global magnetic field. There's nothing to protect the planet from radiation. And the locals' bodies probably had to switch their pigmentation from melanin to carotenoids, the same pigments that give oranges, carrots, and tomatoes their bright color. As for those big, beautiful eyes, they help the creature perceive the light of our now-distant sun much better than regular human eyes. Now, if this is the story you wanted to hear, I'm sorry to disappoint you, because the life forms we've discovered on Mars are very different, and still, for scientists, they are no less exciting. Last year, the Perseverance rover, the most expensive off-roading robot ever, found a dried-up riverbed covered in weird, rusty circles they're calling leopard spots. According to a scientist from NASA, these spots might be leftovers from ancient life forms that lived there billions of years ago. And now, experts think they might know what those tiny Martian critters could have looked like. Once again, we're not speaking about creatures with eyes or tentacles here. Mars is a wild place that gets roasted during the day, then drops to minus 225 degrees Fahrenheit at night. There's low gravity and nasty radiation there, so anything living out there would have been microscopic, bacteria-level small. If, and it's a big if, something more complex ever evolved on the red planet, it would have needed insane superpowers to survive those conditions. Anyway, while cruising around an area called Bright Angel, Perseverance spotted those leopard spots. Scientists call them reaction fronts, basically places where chemical stuff went down long ago. The rover found two minerals in these spots, vivianite and greigite. On Earth, vivianite shows up when organic stuff rots, and greigite is made by microbes, tiny living things. One of the scientists on the team said those minerals look exactly like the kind we find when microbes are involved here on Earth. In his words, this could be the most convincing evidence of life on Mars so far. Of course, there was still a chance these patterns had been made by non-living processes. Nature could have been doing its thing without any help from space germs. But after a year of tests and reviews, and probably a lot of coffee, the team says they're confident this could be a real biosignature. So, what would this Martian life even look like? You see, today, Jezero Crater, a big impact basin just north of Mars's equator, is basically just a dusty wasteland. But billions of years ago, that place was full of water, a real Martian pond. Scientists think that the crater back then had cold, water-rich spots that were perfect for little microbial life. Those microbes could have munched on stuff like carbon, sulfur, and phosphorus in the rocks, and the minerals they produced could be what we see today as those leopard spots. Now, even though the surface conditions on Mars were insane, with freezing temps and all that radiation, microbes could still make it work, just barely surviving day to day. Experts point out that there was actually liquid water at that time, so it means the red planet was technically habitable. Now, since all we've got are these tiny traces, we can't say exactly what Martians looked like or how they acted. But we can make some educated guesses by looking at Earth. We could compare the microbes from Mars with extremophile bacteria on our planet, those tough little guys living in salty lakes, deep underground, or in deserts so harsh even cacti wouldn't bother. Another question is, could anything bigger or fancier than microbes have ever evolved on Mars? Probably not. If those leopard spots are actually signs of life, scientists think microbes weren't just hanging out in one spot. They were likely all over the place. Perseverance is checking out ancient rocks beyond Jezero Crater to see if Mars had a bigger population. But here's one thing. Mars got harsh very fast. Life may have popped up on this planet around the same time as on Earth. But after about 1 billion years, the red planet started losing its atmosphere thanks to solar winds. That turned Mars into a freezing, dry wasteland. The extreme cold, radiation from the sun, and lack of water would have made it super tough for anything bigger than microbes to survive there. Complex life, like animals, took another 3 billion years to appear on Earth, and conditions on our planet were way more pleasant. If anything more advanced ever showed up on Mars, it would have had to be like a superhero microbe with thick skin, or an ability to hide underground to dodge UV rays and survive in freezing temperatures. It would have been living off whatever tiny puddles of water it could find, basically like desert lizards or those weird filter feeders you find near Earth's hydrothermal vents. Now, we might still need to wait before we meet a real Martian resident, but nothing can keep our imagination from wandering. So, how about we sneak a peek at what the inhabitants of other planets of the solar system would look like if they existed and were more complex than microbes? Now, if it was a creature from Jupiter, it would probably be something like a deep-sea tank bug with a thick armored shell, huge googly eyes, webbed claws, and gills. All those features would help it survive Jupiter's crazy high pressure, radiation, and endless liquid layers. Because on this planet, at first, everything is just clouds. But go deeper, and gas turns into a liquid ocean of metallic hydrogen. No wonder locals would need all the protection they could develop. Let's jump over to Saturn with its clouds, rings, and more clouds. This planet is so light it could literally float in a giant cosmic bathtub. Here, you'd likely come across a giant space jellyfish. It'd float through thick fog with an umbrella-shaped body and long tentacles instead of arms. Saturn's pressure is huge, and having a skeleton would just get it squished. Floating and flopping around is the smartest survival hack here. Now, we're going to visit the ice giants, Uranus and Neptune. Both planets are like cosmic slushies of ammonia, methane, and water. Boy. There's no solid ground anywhere, just icy oceans under thick atmospheres. Here, you might meet a stocky, muscled amphibian with stubby limbs, webbed fingers, and scaly skin. All because gravity on the ice giants is higher than on Earth, and the environment is freezing. Any creature living there would need short, strong limbs to survive crushing pressure, swim through icy oceans, and stay warm. Moving back to our neighborhood, the first stop is Mercury. The sun here is so close, it looks 3 times bigger than on Earth. Temperatures swing from instant frostbite to literal oven. If anything could survive here, it'd probably have titanium skin. It would be smooth all over, and sunglass-like eyes would protect it from ultra-bright solar rays. The thing is, Mercury has almost zero atmosphere and intense sunlight. Anything living there would need a body capable of surviving heat and radiation without melting or burning out. Our final stop is Venus. The pressure there feels like you're a mile underwater. Volcanic eruptions are popping off all the time, and the air could melt lead. Tropical. And life forms here would be downgraded to a microscopic blob. No arms, no legs, and certainly no face. Venus is insanely hostile, crushing pressure, molten hot temperatures, and toxic gases. Only tiny microbial life could probably survive here. Given all that, I'll take Hawaii instead.
Frozen plains, icy mountains with their snow-capped tops glistening in the sun, valleys, craters, eternal freezing winter.
Wow. Hello there, Pluto. At first sight, it looks like a paradise for adventurers who love skiing, snowboarding, and all the other fun things you can do in snowy winter wonderlands. But the snow there is not like what you can find on the mountains of Earth. On Pluto, the mountain peaks are covered with frozen methane, while down here they're made of frozen water crystals. Because of its specific chemical composition, the snow on Pluto is red. The mountains themselves are very different too. They reach heights of up to almost 10,000 feet. But they're not rocky like ours, looking more like huge blocks of ice. Such a landscape cannot be found anywhere else in our solar system. But you'll need to pack some layers if you want to come visit. The average temperature there ranges from minus 375 to minus 400 degrees. When taking a look at it from a distance, you can see it has some kind of big, heart-shaped thing on its surface, called the Tombaugh Ratio. That's actually a vast plain the size of Oklahoma or Texas that's covered in nitrogen ice. Scientists discovered this heart actually makes the winds of the planet blow. Craters are also big here, sometimes more than 160 miles in diameter, and some of them show signs of filling and erosion. Erosion is when land is worn away by natural forces such as wind, water, and ice. It's the same process that formed many interesting things that you can see on the surface of the Earth, like valleys, coastlines, peaks, or mountains. The fact that some craters are there because of erosion tells us that tectonic forces must be slowly changing the surface of Pluto. 1/3 of its surface is water, but not the kind that we like to drink, more like a really hard frozen ice. Water is vital for the evolution of life, but not water that's this cold, so it's unlikely that any life has formed here. At least for now. But how do we know all these things about Pluto? Well, here's the basics. Astronomers discovered Pluto in 1930, and just like with plenty other moons and planets, they named it after a figure from Roman mythology, the ruler of the underworld. Pluto was considered the 9th planet of our planetary system until 2006, after which it was recategorized as a dwarf planet. Despite its recent demotion, it is still the largest and the oldest known object in this region of the Kuiper Belt, an outer shell full of other dwarf planets and icy bodies. New Horizons. That was the name of the very first space probe that astronauts sent to have a look at Pluto in 2006. It reached a distance of up to 7,800 miles. While there, it took some important photographs and collected lots of important information, discovered some of the mysterious cosmic oddities found on the surface of Pluto. One interesting thing about this former planet is that it sometimes has an atmosphere and sometimes not. It has an oval-shaped orbit, which means, unlike most other planets, it doesn't travel around the sun in almost perfect circles. As a matter of fact, the sun is nowhere near the center of its orbit. When its orbit takes Pluto closer to the sun, the extra heat warms up a kind of thin atmosphere made primarily from nitrogen, an element our Earth also has in its atmosphere. Right after it's created, it gradually escapes Pluto's weak gravity. When the dwarf planet moves away from the sun, the atmosphere freezes and goes back to its solid state, falling back down to the surface of Pluto as nitrogen snowflakes. Pluto's interior is supposedly warmer than its surface. Some believe there's even an ocean deep underground. Despite being the largest known body in the Kuiper Belt, Pluto is still pretty small. It is smaller than the Earth's moon, around half the width of the United States. It has 5 spinning moons of its own, the biggest one half the size of Pluto itself. Our days last 24 hours, while one day on Pluto lasts 153. Earth needs 365 days to orbit the sun, while a year on Pluto lasts 248 Earth years. So, no birthdays there at all. It sits 3.6 billion miles from the sun, which is 40 times the distance of the Earth stands. If you were standing there, on Pluto, watching the night sky, you'd see the sun as just one small distant star, indistinguishable from the rest. Since Pluto has been demoted, Neptune is now the most distant planet of our solar system. It's also pretty fascinating. It's actually a huge ball of ice and gas. Yes, it's the densest gas giant in our solar system, but you still couldn't stand or walk on its surface. You would simply sink in. But if you could stand, you'd notice that the gravity force is similar to what we have on Earth. Despite its impressive size, though, Neptune is not visible to the naked eye from here. It's the windiest and coldest planet. And 1 year there lasts 165 Earth years. Still no birthdays. It takes more than 4 hours for the light coming from the sun to reach Neptune's surface. Our next gas giant is Uranus. 1 year on Uranus lasts 84 Earth years, so you can maybe get one birthday in there, but you better make it count. Just like Neptune, Uranus can't be seen without the help of advanced technology. The rest of the 6 planets can. But you can still see all 8 of them with binoculars or a smaller telescope. Now, pause the video, see if you can make your astronomy teacher proud, and try to remember which planet comes next in order from furthest to closest to the sun. You got it? That's right, it's Saturn, A+. Saturn is the 2nd biggest planet of our solar system, right behind Jupiter, and another gas giant where you'd sink in if you tried to walk on it. It's so gassy, you could put it in a lake and it would float. They call it the jewel of the solar system because it has a big ring system that kind of looks like a crown. Its rings are made up of dust, pieces of ice, and rock. Some of those pieces are as tiny as a grain of sand, while others are bigger than tall buildings. Next on the list, and completing our gas giant quartet, is Jupiter. Scientists call it a failed star since it's mostly made up of helium and hydrogen, just like the main star in our solar system, the Sun. But Jupiter doesn't have a mass big enough to start the chemical processes that turn it into a star. However, it is still the 5th brightest object in the solar system, right behind Mars. You probably have seen it when stargazing sometime, you just had no idea what it was. Okay, picture all the other planets combined and double their mass. That's a lot of mass, but Jupiter still has more mass than that. It's also the fastest spinning planet, so it takes only 10 hours to complete a full rotation on its axis. Our day lasts 24 hours. Imagine how it would look like to squeeze sleep, work, family, friends, hobbies, movies, all that in just 10 hours. I guess I'd have to sleep once every other day if I lived there. Now, picture this. Magnificent tall mountains, giant dust storms, volcanoes, deep valleys, craters. Mars. That red jewel scientists keep talking about being a potential new home for us. There were even some small meteorite pieces found on Earth that scientists realized were ejected from Mars. That's how close we are. If you love sunsets, you would definitely enjoy the ones here because they're incredibly blue, while the daytime sky is pinkish red. But when on Mars, you'd only see the sun at half its size compared to what we see on Earth. And of course, there's Earth itself. Seas, mountains, valleys, waterfalls, and of course, life. For 4.5 billion years, Earth has been home to so many different kinds of organisms that have lived, died, and lived again. And even though we know so much about our homeland, there's always something new to discover each and every day. The next planet, Venus, is the champion of superlatives. The hottest surface, the closest planet to the Earth, the biggest number of volcanoes, 1,600. If you compare it to other planets to our solar system, the brightest planet, with reflective clouds that make it so shiny you can see it from the surface of Earth. Oh yeah, and the slowest spinning body as well. It takes 243 Earth days for Venus to make just one single turn. You could literally walk faster than the planet's rotational speed. Venus also goes in the opposite direction of Earth, so sunsets there are set in the east, sunrises in the west. And last, but not least, Mercury. It doesn't have any moons or rings, and it's the smallest planet in our solar system. A year there lasts only 88 days. So get ready to expand that birthday budget. Mercury is the planet the closest to the sun, but not the hottest. Venus took that title. Mercury is not the hottest because there's no atmosphere to trap the sun's heat there. But it does have wrinkles. Only 1/2 of Mercury's surface faces the sun at any given time, meaning there's an incredible difference in the temperature on either side, and of course these sides switch as the planet rotates. The iron core of this planet has cooled and contracted over millions of years due to the rapid change in heat, which is why wrinkles have appeared on its surface. Well, that's a brief tour of all the planets of our solar system. And one dwarf planet. Sorry, Pluto. Thanks for watching.
Now, I'll bet you remember the furthest planet from the Sun is Neptune. When European astronomers argued about what to call the newly discovered 8th planet back in 1846, they settled on the name of the Roman deity of the sea. This ice giant is 4 times the size of Earth. And if our planet was the size of a nickel, Neptune would be as large as a baseball. At the same time, the ice giant is 17 times as heavy. If you were approaching this icy world, it would seem blue and perhaps inviting. But this blue surface is actually a layer of swirling gas and permanent clouds. So don't get your hopes up. You wouldn't be able to land on this planet. Its mantle, made up of water, ammonium, and methane ice, is the closest thing Neptune has to a surface. But even down there, there isn't solid ground for you to walk on. Anyway, this distant planet is surrounded by mystery, and astronomers haven't cracked all of it yet. Why are the winds on Neptune so fast? Why does this world shed more heat than it gets? Why is its magnetic field offset? And what is the Great Dark Spot? Well, let's try to find some answers. Neptune is around 30 times as far from the Sun as our home planet. That explains why studying this distant world is so difficult. It also means that the planet gets way less light and heat from our star. But at the same time, Neptune radiates a lot more heat than it's taking. If we compare Neptune to nearby Uranus, we'll see that even though Uranus is closer to the Sun, it emits almost the same amount of heat as Neptune. Astronomers don't know for sure why it happens yet, but of course there are theories because they're scientists. Some experts believe there is something fierce inside the blue planet that causes it to generate more heat than it receives. It might be the reason for Neptune's huge differences in temperatures, from minus 260 degrees Fahrenheit at the planet's rigid cloud tops to more than 12,000 degrees at the core of the ice giant. So you're going to want to dress in layers. Now, such temperature variations might be the reason for powerful windstorms. Their speed can reach 1,200 miles per hour. For comparison, the most powerful winds on Earth move at a speed of 250 miles per hour. Another curious thing about Neptune's winds is that they are blowing westward, which is backward to the rotation of the planet. A study published in 2013 supposed that the winds on Neptune would appear in thin layers no more than 600 miles thick. Such a shallow depth might mean that condensing and evaporating moisture could produce those crazily fast air currents. Then there's the issue of Neptune's magnetic field being offset. If you were to overlay a magnet on this planet, it wouldn't line up with the center. Astronomers aren't sure why it happens. Magnetic fields are produced by moving currents, and all the planets, including Earth, are believed to have some conductive material moving in their bellies. But with Neptune's belly, it's a bit different. Its magnetic field is tilted at 47 degrees to the planet's rotation, which means that the rotation and magnetism aren't aligned inherently. And don't forget about the Great Dark Spot. No, I'm not talking about the most massive storm in the solar system. That one is called the Great Red Spot and is located on Jupiter. I mean a corresponding spot on Neptune discovered by Voyager 2 in 1989. In 1995, the Hubble Space Telescope turned its eye on Neptune, but disappointingly, by that time, the spot had already mysteriously vanished, and scientists have no idea how exactly it disappeared. But guess what? Another dark spot has been found on the ice giant. Astronomers have known for quite some time that, from time to time, Neptune's surface gets dotted with such spots. These bizarre discolorations have been linked to high-pressure areas, coming and going over the course of a few years. But no one has seen a dark spot forming until recently. Since then, astronomers have been observing the birth of dark spots quite regularly. Now they have a much better idea of where and when these huge vortices might form. Now, despite assumptions, astronomers once thought Neptune was a boring, featureless world. The ice giant has a hyperactive atmosphere. It's turbulent, with cloud ripples and severe storms. Plus, this planet has a ring system. Disappointingly, those rings are not distinct hula hoops circling Neptune, like those of Saturn. The ice giant's rings are weirdly chunky and contain gobs of material that form arcs in the outer ring. Astronomers explain that these clumps are actually places where loads of ring particles are stuck together. What it means is still unclear. But my favorite thing about Neptune is this one. Astronomers believe that deep inside the planet, there might be a layer where it rains diamond crystals. Intense pressure and temperature inside Neptune break methane molecules apart, releasing carbon. These carbon compounds find their fellow molecules and create long chains, which then get squeezed together, forming beautiful crystalline patterns like diamonds. When these diamond formations drop through the layers of Neptune's mantle, it gets too hot for them. That's why they vaporize, float back, and, you guessed it, repeat the cycle. Now you know why it's called diamond rain. How about a fun little experiment? Let's say we exploded Neptune, in the name of science, of course. As you already know, this planet doesn't have a solid surface. That's why, after activating the process, you'd see Neptune's liquid mantle burst. It would look like a water-filled balloon thrown down from the 50th floor. Disclaimer, don't do this at home. The impact would send splashes of water, ammonia, and methane ice away into space. It'd be followed by lava-like remains of the planet's mantle, liquid and red hot. And then there would be a hurricane of solid rocks. That's what would be left from Neptune's solid core made up of iron and other metals. Okay, let's put this pretty ice giant back together. I've got one more experiment for you. Let's replace the Moon, yes, our good old satellite, with Neptune. The ice giant is definitely way larger than the Moon. The planet would look like a bright blue hot air balloon in the sky, and we would see it not only at night but also during the day. It would appear to be 15 times larger than the Sun. If everything else remained the same, solar eclipses would seem to continue for ages. Once the Sun vanished behind Neptune's edge, our planet would be plunged into complete darkness for no less than an hour and a half. And since Neptune is also much more massive than Earth, its gravitational pull is much stronger. That's why, instead of getting itself a powerful companion and protector, our planet would end up as a satellite. Yep, Neptune's moon. It would orbit Neptune slightly further than its own largest moon, Triton, and there would be a great risk of Earth colliding with this space body. But let's assume we were lucky enough not to cross paths with any of Neptune's satellites. Even so, we would have more than enough problems. Tides on our planet would be 1,000 times more powerful than those caused by the Moon. Neptune's gravitational force wouldn't pull Earth apart, but it would heat our planet up. Like we need more of that, huh? The seismic activity would increase, setting off earthquakes and volcanic eruptions. Well, that sounds unsettling, so let Neptune remain where it is now. I'm okay with a good old moon. Now we're done with the experiments, but hear me out. Beyond the orbit of Neptune, there's a mysterious Kuiper belt filled with massive icy objects. The most curious thing about this space formation, though, is that scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding another big planet from our sight. Are they in cahoots? This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed. Or not.
We're traveling through space at the speed of light. The route from Earth to the Sun at that speed will take only 8 minutes, but it would take us about 35 years to reach our destination, which is, by the way, still very fast. By comparison, a conventional rocket would take about 600,000 years to make the journey. And here we are. It's a star system suspiciously very similar to our own. And our scientists suspect that life could exist here, just like on Earth. A red dwarf, 30% the size and weight of the Sun, lies at the heart of this star system. But these are the planets orbiting the star that interest us most. The first of these is L9859b. Its size is somewhere between Earth and Mars, but it's very light. It's only half the mass of Venus. But life is impossible on this rocky planet. It's too close to the star, and it's so hot, you'd burn a cake if you tried baking it on its surface. It's about 100 degrees higher than the maximum of your oven. The planet makes a complete circle around its host star in just 2 days, compared to 365 for Earth. And it gets 22 times more energy than we get from the Sun. So it's not only hot there, but there's a lot of dangerous radiation. The next planet is 2.8 million miles from its host star. That's 13 times closer than the distance from Mercury to the Sun. And it makes a complete revolution around the star in 3.7 days. But what's interesting is that the planet is 30% bigger than the Earth and twice as heavy. So it belongs to the class of super-Earth planets. Such planets can be rich in water ice, methane, and hydrogen. These are some of the elements that are necessary for life's existence. Many scientists believe that it's on such planets that extraterrestrial civilizations can live. But because of the great weight of the planet, it has a strong gravitational force. So these civilizations may not be able to fly into space because it's harder for them to get out of the gravitational trap of a super-Earth planet. However, life isn't possible here because the planet is still too close to the host star. And just like in our solar system, the two nearest planets are too hot. But the third planet looks more promising. L9859d. It's almost twice as heavy as the Earth and 50% bigger. Scientists have calculated that about a third of its mass could be water. For comparison, the mass of all water on Earth is only 0.02%. the presence of water is the main condition for the emergence of life. But we can only guess where the water might be. It could be on the surface, but high temperatures can turn large oceans into giant clouds of steam. But water can also be contained in the groundwater below the surface. Well, we can't know that for sure yet. Let's move on to the next planet in the star system. This newly discovered planet is of the Super Venus class, L9859e. It's a rocky planet 3 times the size of Earth. The Super Venus class means that the planet is heavy enough to have an atmosphere, but the conditions there are more like a greenhouse. Different gases fill the atmosphere there. Star rays pass through them to the planet's surface, reflect off it, and rise upward. But the dense gases don't let them leave the atmosphere, so the planet gets hotter and hotter. This is the greenhouse effect that we try so hard to avoid on Earth. On top of that, the stellar wind carries water vapor and other elements from the upper layers of the atmosphere into outer space. Life cannot exist on such a planet, nor could it ever originate, just like on Earth's twin sister, Venus. So far, all the planets we've looked at are outside the habitable zone of the host star. That's the sweet spot at a perfect distance from the star. Not too close so that the planet isn't too hot and the water there doesn't evaporate instantly. And not too far away, so that the planet doesn't look like a cold desert. And planets B, C, D, and E are too close to the host star. But there's another hypothetical planet F in this star system, located right in this sweet spot. This super-Earth candidate is 2.5 times heavier than our home planet. So we have hopes that it's a rocky world, just like the other planets in this star system. The weight of planet F is enough to have a dense atmosphere, and the temperature on its surface should be suitable for water to exist there in liquid form. The planet makes a complete circle around its host star in 23 days, which literally means it's New Year every 3 weeks. It isn't very likely, though, that there's a civilization there that celebrates it. Indeed, the very existence of this planet is very doubtful, because we still have no direct evidence. All the other planets have been discovered by the transit method. That's when we point our telescopes directly at a star and watch its brightness change. When there's a slight drop in the star's brightness, that's when a planet has passed between us and the star, like this dot. We have a short period of time while the planet is in the background of the star to determine its size and speed. Sometimes we can observe such transits of Mercury and Venus on the solar disk. And there are at least 29 potentially habitable planets out there in distant space that can observe Earth in the same way. About 1,715 stars within a few hundred light years are perfectly located for it. Each star has planets around it, but only 29 of them are in the habitable zone. So there really could be life and an intelligent extraterrestrial civilization out there. If so, they could point their telescopes toward the sun and see a small dot pass across the solar disk. And they could have been making these observations for at least the last 5,000 years. So they could see how our civilization was born and how we evolved. Moreover, these planets are close enough to pick up our radio signals and even television broadcasts. But it works both ways. Radio signals travel through space at the speed of light. We mastered this technology about 100 years ago. So if there really is a civilization out there somewhere, we would pick up their signals too. But so far, it hasn't happened. So we have no proof of the existence of life on these planets. The discovery of a star system like L9859 is very important to us because we're always looking for life outside of our solar system. And super-Earth-class planets are even better suited for the origin of life than planet Earth itself. Such planets are sometimes called super-habitable. So some scientists think that Earth is a good place for life, but not the best. Super-habitable planets would have to be 30% larger than Earth and twice as heavy. This would create stronger gravity, which would make the atmosphere on the planet denser and with a higher concentration of oxygen. This in turn would raise the average temperature on the planet to a perfect 77 degrees Fahrenheit, so plants would thrive there. Also, stronger gravity makes the surface of the planet flatter, so there might be more oceans there than on Earth. This would make aquatic life much more diverse. The host star also plays a very important role. It should be smaller than the Sun. The bigger the star, the more of its fuel it burns. This means that the lifespan of such stars is much shorter. For example, the lifespan of the Sun is about 10 billion years, but a red dwarf can live up to 30 billion years. More time, more opportunity for the birth of life and evolution. So far, scientists have discovered 24 superabundant planets, but that still doesn't mean that there is life there for real. But some scientists believe that there are already at least 36 advanced civilizations in our galaxy, besides Earth. They've searched for similar worlds on the star map. First, we find stars that look like the Sun among about 100 billion stars throughout the galaxy. Now we choose from them those that are rich in iron. Such stars burn at the perfect temperature and help the planets around them gain an iron core and become Earth-like. Now let's pick relatively young stars from this pile, because when they get older, they expand and either absorb the planets around them or burn them up. One last thing, let's find planets in this pile that are in the habitable zone of the star. And voila! 36 worlds may be inhabited by some unknown civilization. But we won't know for sure until we get in touch with them.